So we already completed your test 1, question 1 scope on the crystal structure. Then another question for your question 2, test 1 will be in chapter 6. It will be about mechanical properties. Mechanical properties. Okay, I'll just summarize everything for chapter 6. I'm not sure you learned this one in other module. Now we jump from molecule atoms level into macro level where you can see with your naked eye, you can touch with your naked eyes. This also linked to your lab report. Type of loading. Loading, it can be pressure, it can be force, it can be stress. Okay. I tell you the direction of loading first. When the loading is pulling at both ends, writing something on the whiteboard. So if it's pulling at both ends, it becomes, in the question will mention tensile. Means you're pulling both ends, tensile loading. Okay. If the arrow is pointing inside the body, you're pressing, it's called compressive loading, or compression or compressive, same. As long there's a compress there. Okay. You have tensile, you have compress, then you have twist. Twist means this one clockwise, never mind lah, clockwise or anti-clockwise, as long as there's a different direction. Okay, or you can fix one direction and you twist. This will form torsion. Torsion, something like moment, but it's twisting. But we don't use twisting in material science, in engineering material. We use torsion. Okay. Then there's one word called shear. Shear means you force the material in plane. So let's say this is a material, a complete material. Shear means you force the material in one plane like that. It's called shear. Okay, means if you, like for example, you do cutting, you use a scissor to cut paper, right? And that is a shear reaction. You push the material in one plane. Okay, so it's shear. Shear can be an angle. You cut the things in plane. Okay, this is called shear. Okay, then the rest we will go into detail on how to find the equation for tensile, compression, torsion, shear for the loading. Okay, so again, we are using the word loading. Loading can be pressure loading, it can be force loading, it can be stress loading. Okay, what is the difference with pressure? Pressure equal to force divided by area. Okay, what does it mean? Pressure always work perpendicular to the surface. Always pressing the surface, that's called pressure. Okay, perpendicular to the area. Area is the area that touched by the pressure. It's called pressure. So pressure don't pull surface one. Pressure always press the surface. Okay. So this is pressure. Usually on gas, medium, or some physical solid metal, you press pressure. Force, you know lah. Force is a vector that it can be, if the force is pulling both ends out, it becomes tensile force. It's pulling the things, force. If the force is pushing the two end, it becomes compressive force. What about stress? Stress is almost same as pressure. Stress is almost same as pressure. Stress is force divided by area. But this one, the force must be perpendicular to the area. This form stress. Okay. Now it can be stress can be tensile stress, means the force is pulling out the surface, it become tensile. If the force is pressing in, it become compressive stress. So be sensitive to the wording lah. You see the question, what the question want to ask you. If the question asks you to find stress, then you give answer in stress lah. If the question give you force, ask to find force, means you give in force lah. Very rare you see pressure. You see pressure in hydraulic, in module that link with the liquid one. Then you most of the time you see pressure. Okay. So these are the technical words that you see. And you will see normal. The word normal, normal means 90 degree. So like for example, I combine this word normal force. Normal force means force with the area will be 90 degree. Normal stress. Normal stress means the force and the area is 90 degree. Okay. If I use the word shear, just need to be careful on shear. If I use the word shear force will be the force and area will be parallel. If they say shear force at a certain plane, means it's go along the area, the cutting area. Okay. Or the question give you shear stress. Shear stress, you actually taking the force that parallel with the area divided by the area. Like for example, this case, I draw a perfect square object, and you have a force acting in certain angle. Let's say 2D lah, 2D. The force, let's say no lah. I give you tensile lah, theta. This is the area. This force will create two things. This force will give you normal stress and shear stress. SHEAR, shear stress. Both use different formula. If it's normal stress, you need to use the Fy. You need to use Fy divided by area to get normal stress. If you want to find shear stress, you need to use Fx divided by area. Why? Shear, the word shear means you force is go parallel to the area. So don't confuse between the normal stress and shear stress. Okay? If you understand this one, basically we can conclude chapter 6 already. The rest is just detail in calculation, mathematics, and so on. Okay, so just be careful on the wording that we use in chapter 6. Okay, so this one in the introduction, you read lah. Okay, before we go into all the stress or the force, we look at how we produce metals first. The first method is called casting. Casting means you have a mold, Then inside the mold, you got shape that you want to fabricate. Then you pour in molten metal, means hot metal, liquid form. You pour inside, fill in the gap. Then you cool it down, you get the shape of the object. So yeah lah. So this is how we do. Okay. Cast process is for piston, for example, cast products. Okay, so this is for your info lah. Like if you haven't seen any casting process before, this is a mold. Okay, put in the mold, set up the mold. There is a job, a position called mold designer, that the engineer design the mold. The job is to design it. And pour in the liquid. Then cool down. Okay. Another one is called rolling. Rolling. So rolling means two drum that is rolling and keep reducing the distance between the two roller. So press one. So or pass number one, pass number two. So it will go. This is a go and return process. So it go. It's like people selling sugarcane juice, something like that. Go in, then out, going out. Like that. So go in, out, going out. It becomes smaller and smaller. This is called hot rolling. Means the things happen in a very hot condition. You have two type of rolling: cold rolling and hot rolling. Hot rolling is when the metal is hot. Ingot, the word ingot, if you go to industry, ingot means the raw material that you put inside the roller or the press. Ingot, called ingot. This is an industrial process where people produce a metal sheet, put in a lot of roller, go in, become smaller and smaller. So station 1, 2, 3, 4, and so on, then become cooler. So from here, it press 1, 2, 3, 4, 1, 2, 3, 4, then go into smaller and smaller. Okay, so these are the industrial setup and lots of roller. Right now, cold rolling is done in room temperature. There's a two type, cold rolling and hot rolling. Okay. Okay. Again, why we introduce all this process? Because later, in the question, we will tell you what happened to the metal. The metal will go through hot rolling. Hot rolling means you're pressing the thing. You need to calculate compressive stress, force, and all this. Okay. Okay. So the first equation for chapter 6 is called percentage of co-work or percentage of co-reduction. Yeah. First equation for chapter 6, co-reduction, equal to initial thickness minus final thickness divided by initial thickness multiply 100%. So can you calculate the percentage of co-reduction for this case from 3.084 to 0.40? Sorry, 1.016 from 3 mm to 1 mm. what is the percentage of reduction? What is the percentage of reduction? How many percent? Okay, 66 something, huh? So you take the initial minus final, divide by initial, huh? So most of the time, the careless mistake is the denominator. You don't know what to put at the denominator. Okay. When you compare something, you always put the initial at the bottom. So this is quite straightforward. Okay. So this is another exercise. Sometimes the question will not use co-reduction. It will use co-work. Co-work. Same formula. So it gives you a sheet of 70% copper with the zinc, co-roted 20% to a thickness of 3 mm. The sheet is further co-roted to 2 mm. What is the total percentage of co-work? This question come out in the final many times. It's part of the question in final exam. Like final exam, we have ABC. This is part of the ABC. Okay, for your test 1, question 2, this one also part of the question. So total how many? Do you see the way we try to ask you? You need to find what? It give you a 20% co-road here. It give you the left-hand side equation. Something missing in the equation. What is missing? What is missing in the equation? Initial thickness. So you need to find the initial thickness through the first step, the first line. It give you 20% already, and the final thickness give you. So using this equation, left-hand side given, something missing, initial thickness missing, rearrange the equation, solve this equation. Okay, so what is the initial thickness? If you work back the equation, can you calculate? What is the initial thickness? Okay, percentage of reduction or percentage of co-work equal to initial minus final divided by initial, multiply 100%. So basically, you can take out the percentage by writing 20% equal to 0.2 on the left-hand side, because you move 100 from right to left, divide 100, right? So what is the initial thickness? It should more than 3. If your answer less than 3 mm means wrong already. It should be what? 3 point what? 3.2, right? 82? 3.2? I don't think so. It's 3.2. 3.2. Okay, let's see. I don't remember the answer. Okay, so means you put in things, it's 3.75, not 3.2. 3.2, it will be less than 20%. So check your calculation. Something missing in your calculation if you get 3.2. What is your mistake just now? Why you get 3.2? What is different from the slides? How you get 3.2? What's your mistakes? I think mathematics side lah, because x you pull here become 0.2x ma. So if 0.2x pull to the left become 1 minus 0.2 get 0.8. So this one you pull to the right, you get 3. 3 divided by 0.8, you should get 3.75. Okay, so you get the initial before sampling. Then you start to co-work to 20%, and 20 at the final dimension is 2 mm, right? So straight away you take the initial minus the final divided by initial thickness, because the question asks you total percentage of co-work. Okay, in previous, the final answer is 46.6. Previous final exam and also test one exam, test one question, we reverse the question. We reverse the question. We give you the total co-work, and then we give you something in the storeroom with the metal in the storeroom with already co-work at a certain percentage. Then we ask you the process. How many co-work you need to do on that particular object or particular metals. Okay, so for this module, it won't be direct. You need to think a little bit. Then think, how do I apply that value? It won't be that direct in this module. So you need to think and apply the knowledge. Yeah, so there's one question come out in this from this question in the final last semester. So I reverse the question. I give you a total reduction. Then I will add in some mechanical properties later lah. Then I'll combine this question. You need to tell me what are the process. Do you need to cold roll it? You need to hammer it to reach a certain mechanical properties. Okay, so later you will see one chart, something like this. Percentage of cold work means the one you are calculating, this one, with the properties. You have mechanical properties, a lot of mechanical properties. So they are lined there. Let's say the customer want this region. You need to control the percentage of co-work in your process, for example. You need to come up with a recommendation. You tell the operator, okay, you cannot reduce until what? There's a range that you need to tell the operator, because we train you to become engineer. So you need to come to a level where you need to tell the operator what to do. Okay, so this is another one. It's called extrusion. Extrusion means you press the things like you squeeze pimples lah. Squeeze pimples. So you press from the back. Okay, it's called extrusion. I hope the Wi-Fi is okay.
The primary type of hot extrusion is direct or forward extrusion.
Cylindrical ingot.
Indirect extrusion. The hot billet is loaded into a thick wall container and forced through an extrusion die secured in a holder. The force for extruding is applied by a ram, along with an intermediate reusable dummy block. Metal flow from the die is in the same direction as the forward motion of the ram. Since the surface of the billet length slides along the wall of the container, extrusion force depends on the friction between the billet length and the container and the material. The friction portion of the force can be reduced by using lubrication. Force increases rapidly as the billet is upset to fill the container, then increases further as breakthrough force before extrusion begins. Upon breakthrough, the force declines as billet length decreases until a minimum force is reached. As the billet thins,
So there
the
will be
force
heat
rapidly rises
generated in
again
this
to
section.
continue metal
So when
flow
you design this
radially
kind of
toward the
mold, you need
die
to be
opening.
careful on the material expansion.
Resistance to deformation
If
or
not,
force
then the
requirements
size will be
increase
different from
markedly
what you
as the
design.
thickness of the butt or unused billet portion decreases.
Okay, this is basically the concept. Extrusion. So they are direct extrusion and indirect extrusion. So on the left and on the right, I hope you can see the difference. The left-hand side is direct extrusion where the ram is moving. Okay, the left-hand side direct one, the ram is moving. So there will be product input and output. So the output extrusion will come out. The control here is die. The die is the one that gives you the shape you want. Okay. So on the right-hand side, indirect. You see indirect is the ram is moving also, but the ram and the die combine together. Then you press the die with the ram. The billet is stationary. Okay, so it's on the left hand side, direct and indirect. Usually the B indirect will be more expensive compared to the left hand side. Because there is a different setting on the ram and the die here. So if something wrong with the die, you need to change the whole thing. Rather than left hand side, if the die broken, you just change the die. If the ram broken, then you fix the ram. Okay, so this one is aluminum case extruded. So it's a similar process like what you see. As you know how things work.
Sapa Extrusions is the world's leading producer of extruded aluminum products. Headquartered in Oslo, Norway, we employ over 23,000 people worldwide. In the Americas, Sapa operates 25 locations across the United States, Canada, Argentina, and Brazil. Our products include extruded aluminum solutions for virtually every market: building and construction, automotive, solar and renewable energy, thermal management, fabrication and machining, commercial transportation, and more. Sapa aluminum is the strong, lightweight, renewable material behind many of today's most innovative product designs. Aluminum extrusion is the process of using high pressure to force aluminum material through the shaped opening of a steel die, creating an extruded aluminum profile or shape. In brief, the heated aluminum billet is placed into a steel cylinder or container, then forced through the container by a ram under as much as 100,000 pounds per square inch of pressure. A die stack at the far end of the container holds the opening through which aluminum is extruded to form the desired shape.
So this is a die.
Once the material is extruded, it will be cooled by quenching.
They have water to cool
stretched
down
for straightness,
material.
sawed to working lengths, and then inspected. Finally, the extrusion is aged to desired temper,
to age the material.
tested for physical and chemical properties,
Okay, so this
further
is
fabricated
QA
as required,
section.
and packed for shipment.
Okay. So to do all these
let's look at each step more.
Okay, so I think the link has been not. Another one is called forging. Too bad the link is not there. Let me see to take. Okay, don't have. Okay, forging will be, it depends on the parts. So forging means you press the things like a hammer, flat dies, V dies, V shape, sauvage round, V dies also on the top and bottom. Okay, forging. Forging will be like casting, but this one Casting without force. You're not pressing the things, you just pour and let it cool down. Forging, you press the things like you are making Lego, not Lego, like pressing the soft things. Okay. Wire draw is like extrusion, but this one for metals. So the same thing lah. It's still extrude, but it's keep reducing the things.
After removal of the iron oxide layer,
Okay.
the wire
You
is
see
lubricated.
it reducing
A
the
powered
diameter
capstan draws it
from
through a die, reducing the
one station to
diameter.
another station.
Further reduction can take place using
It's
extra
like another type
dies.
of extrusion.
The drawn wire
But the
is
word
finally wound on a
wire, because
spool.
it's what you
This
produce,
transformation elongates the wire. 1 meter of 5.5 millimeter wire rod can be drawn to 30 meters with 1 millimeter diameter,
then go
or
to
484
another one
meters with
to
0.25 millimeters
reduce the
diameter.
size again.
The process increases the tensile and yield
All
strength
the
while
big
reducing
drum here is
ductility.
to reduce space actually. They don't need a very long space to do it. You just wire it and wire it. Okay, so this one you go and see. This one is in China. This factory in China. This video is reverse from end to the front. Go and see lah. Deep drawing means do punching and then get the shape. Okay. Now we start to go into analysis of stress and strain. So I think we cover this one before we call it a day. Okay, so if any pieces subject to force, like what I draw on the whiteboard, or this one, the sample subject to force, and based on arrow, you know this one is called tensile loading. There is a deformation happen. So deformation happen. The way metal behave will be represented by a graph. We call it tensile graph. Okay, this is a stress. This is a strain. So I'll explain. So you will undergo elastic. There will be a region where, what I mean by elastic? You pull, you let go, it will go back to original length. That's called elastic. Okay, you pull, you let go back to original length. It's called elastic or recoverable deformation. Okay. This one you read, means the atom go back to its original things and then and so on. But I won't ask you this one. Okay. After elastic, we'll go into plastic. Okay. So first one is elastic. Elastic. Elastic means it will go back after you pull. Next stage, after you go past elastics, means you apply forces that give it elastic. So if the force is too large, the length will maintain. This is original length. When you pull, it's like bubble gum. You pull, you let go, it stay at the last position. You pull, it stay at the last position. That's called plastic. It's like bubble gum. You pull bubble gum. Okay. So we don't want plastic to happen in our application. We want to make sure our force, our load, our stress keep in the elastic region. Okay. So the atom is permanently displaced. Something like this. So it will stay at its own form, for example. Okay. So this one I already explained. So this diagram will help you to understand. Unloaded will be look like this. If the arrow pointing out become tension, pointing in become compression. There's one more bending I didn't show you. Bending you learn in other module. Bending. Shear. Shear, you see the cutting is the same area, same plane, parallel, but the force is from the left and right. Okay, for shear, the force can be left and right. Torsion, twisting, combined loading means you combine any one of these, become one. You learn bending in static also, static and dynamics, or other mechanical things. Okay, so tensile stress, forces, strain. Okay, so strain, okay, there are stress and strain. Just now, I forget to tell you there is a stress and strain. Okay. Stress linked with force and area. If you see the word strain, is actually deformation. You calculating the deformation. For example, what are the deformation can the object do? It elongate, means you measure the change of length. If you pull metal, it will become reduced diameter in the center. If you pull, so it will reduce area. That one also strain. There's a formula for that. So if you see the question asks you stress, you only deal with force and area. If the question asks you strain, is anything that beside force and area. It can be length, it can be diameter. As long as there is a deformation happen, change of shape happen. Okay, first we introduce you the normal stress. Okay, normal stress on engineering stress. So if you pull and metals with the area and length, okay, so this metal's original area is here, length will be here, LO, and because under a loading, a force loading by 2N, the length become the L, from LO to L. Area, in this case, we assume it maintain. In this case, we assume it maintain, do not change any area. In realistic, yes, in the real case, A will change. In this case, we assume area doesn't change. So the formula to calculate will be normal stress will equal, we'll use the sigma symbol to represent stress. Sigma or stress equal to force divided by area. And remember, the area that you use will be perpendicular to the force. Is the area that perpendicular to the force. Because later we'll look into shear stress, you might confuse with the area. Or you might confuse the force. Okay. Okay, so can you calculate for this one? Then we call it a day. You have a 12.7 mm diameter aluminum bar subject to tensile force of certain Newton. Calculate normal engineering stress in Pascal. Okay, what mean by Pascal? Pascal is 1 Newton over meter squared. Because F is Newton, area is meter square. Newton meter square equal to Pascal. You solve question, draw the object first. You need to draw something. Draw the object with the diameter, with the length. In this case, you don't need length. Straight away apply the formula. Here is you need to calculate the area with its diameter, which is a round object. Round object equation for area is what? How to find round object area? Pi r square or pi d square over 4. You press calculator. Right, you draw the diagram, then you write this one. And normal stress, or you can just write stress equal stress sigma equal force divided by area. In the test, you don't need to tell me what is capital A. For this module, capital A will represent area. Or if it's chapter 3, chapter 2, A represent atomic number, means how many gram of that element. Okay, so it's understandable. It depends on the question, but if you use A, we understand that you are actually referring to area. Okay, I'll show you the answer. So we use sigma sub n to represent normal stress or engineering stress equal to 1102 Newton divided by the area. The answer will be 87.78 megapascal. Okay. Exercise 3, your homework, go and do. Go and do exercise 3. Next lecture, we do strain. Okay, we stop at exercise number 3.